Hello, my dear students. This is Sushil, lecturer in physics. So today we are going to discuss about the topic units and measurement. So basically, as you all know, CBSE has deleted lot many concepts, lot many things from this chapter. So here is a small brief introduction about this chapter, units and measurement. So let's see what are the topics we are having in this chapter and we'll be covering throughout this module. So units and measurement. The first thing what we are going to discuss in this chapter is nothing but physical quantity. So what is a physical quantity? So in simple words, I can say that a physical quantity is nothing but anything that can be measured. Okay, any quantity that can be measured and expressed in terms of some numerical value, I can call it as a physical quantity. So what is a physical quantity? Any quantity that can be measured. Okay, any quantity that you can measure is basically called as a physical quantity. Now you can say, take an example of say length, mass, velocity, temperature, area, volume, and so on. So any quantity, basically what you can measure and express in terms of a numerical value, that we call it as a physical quantity. And you can see the example length. Say you have a table, okay, you have a table and you say that the length of this table is say around 150 centimeter. So basically you can measure the length. So anything what you can measure, that is called as a physical quantity. Non-physical quantity. So my dear students, if you use your common sense, now it's all about the game of common sense. So if you use your common sense, can I say that a non-physical quantity is a quantity that cannot be measured? Am I right? So a quantity that cannot be measured is called as a non-physical quantity. So can you measure love? So can you say that, okay, this person loves me this much, or this person doesn't like me, or this person hates me so much? But can you measure that hatred? Can you measure the love? Can you measure your emotions? You cannot. So any quantity that you cannot measure or you cannot express in terms of numbers, that is called as a non-physical quantity. I hope you guys are clear. So let's move ahead and let's quickly answer some small MCQ questions. Which of the following is not a physical quantity? So let's see. Option A, length. Option B, mass. Option C, time. Option D, air. So basically, you can measure length, you can measure mass, you can measure time. So the right answer here is air. Let's move ahead. Which of these is a physical quantity? Acceleration, like, dislike, hatred. So my dear student, what do you mean by physical quantity? Any quantity that you can measure. So can you measure hatred? No. Can you measure dislike? No. Can you measure like? No. So what is the answer, my dear student? So the right answer is acceleration. Let's move ahead and understand the standard definition of physical quantity. So let's check out. So any quantity which can be measured directly or indirectly, or in terms of which any laws of physics can be expressed, is called as a physical quantity. There are two types of physical quantities. Okay, one is called as the fundamental physical quantity, and the next one is called as the derived physical quantity. So basically, there are two types of physical quantities. One is the fundamental physical quantities, and the second one is derived physical quantities. When you see this word derived, I hope some idea you will be having right now, but need not worry, we will understand what do you mean by a derived quantity. Let's go ahead. So what is a fundamental quantity? So my dear students, in simple words, fundamental, can I say something which is not depending on anybody? So something which is being fixed. So fundamental quantities are also other quantities which do not depend on any other quantities. They are basically independent quantities. Okay, what are fundamental quantities? They are independent quantities. They don't depend on anyone. So let's check a physical quantity which does not depend on any other physical quantity for its measurement is called a fundamental physical quantity. So what is a fundamental physical quantity, my dear students? A physical quantity which does not depend on anyone. So it's an independent quantity. Such kind of quantities are called as the fundamental physical quantities. I hope the concept is clear. Let's move ahead. So fundamental quantities, my dear students, this is a very, very important question. So basically there are 7 fundamental quantities. Let's have a look right now. So the first one, length, the SI unit is meter, the symbol is meter, M. Mass, the SI unit is kilogram, the symbol is kg. Time, the SI unit is seconds, the symbol is S. Thermodynamic temperature, the unit is Kelvin, the symbol is K. Amount of substance, the SI unit is mole, and the symbol is MOL. Electric current, the SI unit is ampere. My dear student, the spelling of ampere is very, very important. It's AMPERE. Be careful. Students have a tendency to write the spelling AMPHERE. So I'm telling you already, my dear students, be careful. This is the wrong spelling of the unit of current. And the symbol is capital alphabet A. Luminous intensity. What is luminous intensity? Basically, it tells you how bright a light is. Okay, so you can see here, it's a measure of intensity or brightness of light. And the SI unit is candela, and the symbol is CD. Okay, so my dear students, these are the 7 fundamental physical quantities. With this, we have 2 supplementary quantities. That is nothing but we have plane angle, okay, that is radian, the symbol is RAD, and we have solid angle, that is steradian, and the symbol is SR. So my dear student, this is very, very important question. Mention the 7 fundamental quantities. So let's have a quick recap. The first one is length, SI unit is meter, symbol is M. Next one is mass, kilogram, kg. Time, second, S. Thermodynamic temperature, Kelvin, K. Amount of substance, mole, MOL. Electric current, ampere, A. Luminous intensity, candela, CD. And then we have 2 supplementary units. That's plane angle, that's radian, RAD. Solid angle, steradian, SR. Let's move ahead. So what are derived physical quantities? Let's understand. So my dear students, let's use again common sense. Whenever I talk about common sense, you need to understand the concept is very simple. What was fundamental quantities? They were independent quantities. But can I say now derived quantities are the quantities which depends on something? Yes, absolutely. So a derived physical quantity is a quantity which is being derived from the fundamental physical quantities. So derived quantities come from where? They come from fundamental physical quantities. So let's check out the physical quantities which is derived from more than one fundamental quantity is called as derived physical quantity. Let's take some example. So you have area, density, force, acceleration, work. Now you might ask me how. See, area, can I say area is basically length into breadth, or can I also say length into length? So length is which quantity? It's a fundamental quantity. Density, how do you define density, my dear? So density is nothing but mass by volume. What is the SI unit of mass? Kilogram. Now what is volume? L into B into H. So again, the unit here is meter, which is again a fundamental physical quantity. So can I say density is derived from 2 fundamental physical quantities? Yes or no? Let's understand. Let's take some more examples of derived physical quantities. So velocity. So check velocity. The unit is meter per second. But how do you get velocity? Velocity is displacement by time. Do not worry, my dear students. You have studied about velocity in your grade 9. In case if you have forgotten, you have the next chapter, that is motion in a straight line, where you'll be learning again what is velocity. So right now, velocity is displacement by time. The SI unit of displacement is meter. The SI unit of time is second. So there are 2 fundamental quantities involved to get a derived physical quantity, that is velocity. Acceleration. So what is acceleration? Do not worry. Again, you will be learning this in case if you have forgotten your 9th grade concept. So acceleration is basically the rate of change of velocity. So acceleration is velocity by time. So the unit is meter per second square. What is work? Again, ninth standard. So work is nothing but basically force into displacement. So it's a product of force and displacement, and the unit of that is joule. And how do I get kg meter square per second square? I'll explain you, my dear student. So work, as I said, it is force into displacement. Force is mass into acceleration into displacement. Mass unit is kg. Acceleration is meter per second square into displacement is meter. So what do I get? I get kg meter square s power minus 2. So that is the unit of work. So as I said, work is force into displacement. I hope, my dear students, you're getting the concept. It's very simple. Let's solve some MCQ and let's see if you have understood the concepts or no. The first one, a quantity that can be measured is called dash. Physical quantity, non-physical quantity, quantity, or either B or C. Any quantity that can be measured and expressed in terms of numerical value is called as physical quantity. Let's move ahead. The physical quantities which are expressed in terms of more than one fundamental physical quantity. So any quantity that is expressed more than one fundamental quantity is called as. So my dear students, I think it cannot be supplementary units, it cannot be physical quantities, it cannot be fundamental physical quantities. So the right answer, I'm sure most of you have given this answer right, that's derived physical quantities. Let's move ahead. As you can see on the screen, you have already studied what are derived quantities. So let's move ahead and understand. Okay, the next question. There are dash fundamental quantities. So I think you do not need any options here, and you can directly tell me the answer is 7. Okay, so you have already learned that you have mastered this topic. That is, there are 7 fundamental physical quantities. Let's move ahead. Acceleration is a derived physical quantity which depends on how many fundamental quantities? So acceleration, my dear students, you told me acceleration is the rate of change of velocity, velocity by time, velocity by time. So can I say the answer is 2? Absolutely, that's the right answer. So acceleration, so you can see velocity is displacement by time and acceleration is velocity by time. So that's why there are 2 fundamental quantities involved there. Let's move ahead. Charge is a dash quantity. So my dear students, do not worry. You have studied in your 10th standard. There was a beautiful chapter named electricity where you studied current is the rate of flow of charge. So can I say charge is I into T, that's current into time. Yes. So charge is which quantity now? Can it be fundamental? Can it be derived? Can it be non-physical or supplementary? I'm sure these two cannot be the answer. Is charge a fundamental? See, current is a fundamental. Time is a fundamental. But you can see charge is being derived from fundamental. So the right answer is the derived quantity. So you can see on the screen. Okay, so that's the same thing what I've told you. So current is a fundamental, time is a fundamental, and charge becomes a derived quantity. Superb. Now let's go to something called as units. So what are units? So basically whatever is measurable, that quantity is called as physical quantity. I hope everybody is clear with this concept. Any measurable quantity is called as physical quantity. So we have learned this. And a physical quantity is nothing but multiplied in terms of magnitude and unit. Now what is that? Let's understand. Do not worry about that. A physical quantity is magnitude and unit. Okay. What is this? Let's understand. Say, for example, distance. Say 25 kilometer. Can I say this 25 is magnitude? Magnitude in simple words is nothing but numerical value. What is magnitude? It's numerical value. Kilometer is the unit. So I can say magnitude is a measure of magnification of unit. So in simple words, it's a numerical value. And you can see kilometer is unit. So that is why it was said a physical quantity is magnitude into unit. So it's magnitude multiplied by unit. So unit is a standard reference which is used for measurement of physical quantity. So say for example, distance, I say kilometer, time, I say hours or seconds or minutes. I can say weight. Okay. For example, I can say mass as kilograms, grams, pound, all those things. So they are basically unit. So unit is a standard reference which is used for measurement of a physical quantity. So let's move ahead. So what is unit? You can say a measurement of any quantity which involves comparison with a certain basic arbitrarily chosen internationally accepted reference standard is called unit. So again, there are two types of unit, my dear students, basically fundamental unit and derived unit. So fundamental units are the units of fundamental physical quantity. Derived units are the units of derived physical quantity. So it's a simple concept. So the units for fundamental quantities are called fundamental units, and the units of all the other physical quantities can be expressed as a combination of fundamental units are called derived units. So in simple words, derived physical quantities units are called as derived units, and fundamental quantities units are called as fundamental units. I hope the concept is clear. So let's move ahead. Let's answer a few questions. Dash is a standard used for the measurement of a physical quantity. So what is a standard used for the measurement of physical quantity? Can I say it's unit? Yes, the right answer is unit. Unit is a standard used for the measurement of a physical quantity. Let's move ahead, my dear students. So we have system of units. So basically there are three system of units. So the first one is FPS, CGS, and MKS. So FPS stands for foot, pound, and second. CGS stands for centimeter, gram, and second. MKS stands for meter, kilogram, and second. In order to avoid all this confusion, we had something called as SI units. So let's see now. So CGS system, where the length is measured in terms of centimeter, the mass is measured in terms of grams, and the time is measured in terms of second. We have MK system where the length is measured in terms of meter. Again, I'm telling you, my dear students, some of you have a bad habit of writing this as mass. That's a wrong answer. It's not mass, it's meter. Keep that in mind. K stands for kilogram, that is mass, and S stands for second, that is time. And the last one is FPS, that is foot, pound, and second. So my dear students, in simple, if I have to explain you, remember it as CGS, MKS, and FPS. This entire thing stands for length. The next row stands for mass, and the last one is for time. So now it's simple. Length, centimeter, meter, foot. Mass stands for what? Gram, kilogram, and pound. And the last one is very simple, that's second. So I hope, my dear students, the concepts are crystal clear. So here we come to the end of unison measurement part 1. Okay, so I hope you have liked this video, you have understood the concept. So the important thing in this entire part 1 is the 7 fundamental physical quantities. That's a very, very important question, and it can come for 2 marks. And we had few MCQ questions to make you understand the concept. So stay tuned. Do like the channel, do like the video, do subscribe to my channel, and keep sharing. And stay tuned for the next video, that is part 2 coming soon. Thank you so much.